you. Thank you and good morning. It's a pleasure to speak to all you folks today. My name is Aditya Bansod, and today I want to talk to you about building mobile HTML5 applications in hours, not days. And I presented this talk a while ago at the Fluent conference in San Francisco, and I'm very fortunate and thankful for O'Reilly to give me the opportunity to present this again for the webcast and web audience. Today we're going to talk about three-ish core topics. One, we're going to start with a survey of mobile HTML5, take a look at what technologies and capabilities are available, as well as take a look at the state of mobile HTML5 across browsers. We'll then move on to a discussion of how to look at application development and the technologies that are available for application development. From there, we'll close with our Sencha Architect product, which enables developers to actually build applications in a very visual-first, very visual-friendly way. So I'm going to go ahead and jump on in. As Yasmina said, feel free to add questions into the questions and answers pod, and we'll be happy to cover those at the end of the presentation. So at Sencha, you can feel free to get in touch with me either over Twitter or at my email address, aditya@sencha.com. And the core thing that we're going to try to address today is the fact that mobile app development is hard. You have a lot of platforms. You have constantly changing screen sizes. You have constantly changing device capabilities. And what you end up faced with is a situation where this is your device landscape. Not only do you have a variety of different screen sizes, you also have a variety of CPU power, JavaScript engines, native capabilities, native platforms, input methods, whether it's touch or keyboard, and a whole host of other problems that you as a mobile application developer have to face. You have a couple choices to go. Clearly, you can choose the native route, and that works great in a lot of cases. You have the choice of Android or the Apple platforms, RIM and the new upcoming Windows Phone platforms, or other cross-platform technologies such as Flash or maybe even Java. Now, when we talk about the HTML5, I use it as kind of a broader moniker. I use it as a moniker or as an expression for the way that the web is changing. The way the web is changing away from a pure document-focused mechanism where you browse and consume to a more application-driven mechanism. And we'll see how this applies to the mobile ecosystem in a brief second. So if you look at this data here, this is a little bit on the older side. It's about a year old, but it's just as accurate of a picture. I think the only major difference here is RIM's slice of the pie is slightly smaller now and Google's is slightly larger. You see that they're effectively in North America and largely in most parts of the world, so you have three major players in the smartphone ecosystem. Google, clearly, Apple, of course, RIM but shrinking, and then Microsoft with Windows Phone 8 will be a player very soon. Now, if you're an application developer, whether you work in an enterprise, whether you work for a business, whether you're trying to build a consumer application, and you want to build an app that spans all these devices, especially with the growth of Android in the last year, you have a choice again. You can pick a native language, a native environment, and on the Android universe, you'd have to go with Java or their NDK, which is a C++ set of APIs. Apple, clearly, you go with Objective-C and the Cocoa APIs. And on the RIM universe, you have to go with J2ME, or in the BlackBerry 10 and Playbook universe, you go with Adobe Air. It's really even worth mentioning that between, we say RIM is J2ME, and Android is Java, they're very different Javas. The APIs are different. The language is the same, but the underlying APIs are different. And then if you're going to target Windows Phone, you've got a whole other ball of wax to deal with, which is the C# ecosystem, which is Microsoft's programming language, and then the Windows Phone APIs. Now, if we look back and consider this in the context of HTML5, there's really only one browser platform on these devices. Between iOS, Android, BlackBerry, you have Webkit as a mechanism and as a common middleware tier to actually target. This is actually really interesting because if you look at the mobile stack and if you look at mobile browsers and mobile hardware, Webkit is, after the radio, the most prevalent piece of middleware technology that exists in mobile devices. Now that's incredible, and that's incredible for two reasons. First of all, you finally have one platform from which you can actually look at that's relatively consistent across platforms. And two, it's impressive from the fact that it's actually so capable these days. And with so many technologies and techniques available inside of WebKit, you have an incredible power to actually address these. So it's a fair question to ask, well, what about Windows Phone 8? And what about IE? So we've been closely tracking IE 10, which is a version of IE that's going to ship in Windows Phone and also in Windows 8. And so far, from what we've seen in the preview devices they've released and on what they've shown on desktop and with the tablet form factors, is it's a very capable HTML5 browser. And that's incredible for, because it allows us to actually treat IE as a first-class citizen, being able to use a lot of the techniques that were pioneered in the WebKit community and were standardized as a part of the HTML5 track, but now use them as a part of the Internet Explorer 10 code base and application that target IE 10. So for the first time, we're in a position now where we're using one language, that's JavaScript, one markup system, that's HTML, and one style system, that's CSS, to target a wide variety of devices. If I was to give this talk a year ago, maybe even 6 months ago, this would have been even less true because IE 10 was an unknown quantity. But now we actually have a proper language, a proper markup, and a proper style system that gives us the ability to actually use one platform and one stack to actually get advantage and take advantage of all these various different mobile operating systems. And that stack obviously is HTML5. So if you look at HTML5 a little bit more holistically, and you look at all the capabilities that are in the spec and then that are somewhat out of the spec but are being developed as a part of the standards track, you'll see three key sectors that we had actually mentioned earlier. You have HTML, which is the markup, JavaScript is the programming language, and CSS for styling. But that's not it. Those basic capabilities are just the beginning of what HTML5 and the web platform actually has to offer. So let's start from the top. Not only do you have this core layout ability, but you also have now capability for web fonts. So any kind of rich typographic layouts that you want to do that use your own fonts for your own branding, you can now bring those in. And there's great services to enable that, such as Typekit, such as Google Fonts, that actually give you the service on top of the core engine that the browser provides. You also have video and audio with the new video and audio HTML5 tags. There's discussion and debate around video codecs, around which are the appropriate codecs, but by and large you have the ability now without any plugins to play back video on any mobile HTML5 capable browser. So it's incredible. So you can actually do inline audio and inline video. Then you have fonts, you have audio visual, you also have graphics capabilities. And the graphics capabilities of the HTML5 stack have progressed incredibly in the last 2 years. You have Canvas for doing free-form drawing, and you have SVG now very widely available for not only doing vector-based drawing, but also for doing transformations, effects, blend modes, all sorts of rich graphics capabilities, all by using SVG as the language to speak to the browser rendering engine. So core rendering. Underneath that, you have core app services. So you have databases with IndexedDB and WebSQL, as well as local storage to give you a key value storage inside the browser. You also have an app cache to let you store your actual HTML or your CSS or your JavaScript inside the browser, so you don't actually have to hit the network. The next box over, you have workers and parallel processing, so you can actually start to do more complex computations in the browser. And then also cross-app messaging with a new API called PostMessage, which lets you talk to different applications and actually have an entire web ecosystem where apps are communicating with one another, whether it's through PostMessage, and so they don't have to rely on a server to do that anymore. On the right side is your typical set of network layer APIs, whether it's HTTP, AJAX with XML HTTP request, the event system sockets, and SSL, including the new WebSockets capabilities to let you do real low-level networking out of the browser. And on the left side, and this is admittedly the weakest part of HTML5 and the weakest part of the browser, is device access. The camera is now available to us in iOS 6. It was available to us in Honeycomb on the Android side for a few years now. But now you can actually specify an input type in a form, and when you hit Browse, the browser will present to you the native iOS camera widget, so you can actually take a new photo or upload a photo from your camera roll and upload it to the web server. We've had location capability for about 2 years now, So location capability lets you, query the geolocation coordinates. Contacts, not available yet. It's coming hopefully soon, as well as SMS, also not available but coming soon. Orientation and the gyroscope, so the accelerometer, these are all available. So when I look at this picture and I kind of step back and I remove a lot of the labels, what it looks like to me is a complete application development platform. If you change the names of the actual technologies but you had the same boxes, it would look identical to the Android platform. It would look identical to the iOS platform. It would look identical to, say, a Java platform. So now the web and HTML5 have evolved to a point where you have a full, rich capability to build and create applications. So you have all the elements of a modern app platform now. Very powerful, very rich, gives you the capabilities to build some amazing applications. Now, a common question we get when we're talking about HTML5 is, well, it's so diverse. It's so fragmented across the various browsers. And that used to be very true. There's no arguing the fact that that was actually the state of affairs. But in the last year and a half, it has gotten radically, radically better. If I was to show you this chart about a year ago, it would look like Swiss cheese. There'd be holes all over the chart. The left side contains, the chart along the left side contains all the APIs that are available in the browser as a part of the HTML5 spec. The middle column shows the desktop browsers, i.e. Chrome, Safari, and Firefox. And the right side shows the mobile equivalents, mobile iOS, mobile Safari, the BlackBerry 10 browser, Android. And we don't have it on the chart yet, but IE 10 was going to look very, very similar. So places where, we didn't have SVG in Android until Honeycomb, now we do. We didn't have media type and camera support, but now we have it in iOS 6, and we have it since Android Honeycomb. We didn't have things like font face in earlier versions of Android, and now we do. So we see really for the first time a very, very rich, comprehensive, cross-platform application development platform. So there is diversity still, and there are a couple tools that you can use to help yourself understand when you're building mobile HTML5 apps how to stay on top of this. One of the ones that we love a lot here at Sencha is a website called Can I Use? And what it is, it's just a way for you to actually take a look at every browser, basically, and to see whether or not that API is available in that browser, and what version it was available on, and how compatible the implementation is. And again, based on my prior slide, you can see that that has gotten much better over the last couple years. Modernizer is a great library that's available to let you, inside your code, make dynamic decisions based on availability of APIs. And then Device Atlas is actually a hardware guide which shows for various phone types what are the capabilities and what are the features of that specific piece of hardware. So it's very easy to stay on top of diversity, and diversity is becoming a smaller and smaller problem every year. But as you kind of look, the web is still evolving, and you have a set of capabilities and the specs that go out on the bottom side of this, and then the number and the volume of browsers that's supported in the kind of top column. So in the ideal world, we have every browser supporting every feature. That's clearly not true. And even if they did, some of them don't support it well. We have problems with older or slower Android devices rendering poorly. And so the browsers have a fall off in capability the more you actually ask from them. So there's a technique called polyfills. And polyfills basically provide you, they're small little JavaScript libraries that provide you the filling in, if you will, of missing capabilities. It's a term that was invented, I think, by Paul Irish. He's at Google now. And the example I give here of the best of a polyfill is an API that's available in more modern browsers called Request Animation Frame. So a lot of people, when they're trying to do animations on a browser, whether it's mobile or desktop, animations require a guaranteed interval so that you can know to move something. If you're animating something at 20 frames a second or 30 frames a second, you need to get called 20 or 30 times in a second so that you can move and animate the object to the right place. Not every browser has that capability called Request Animation Frame with a guaranteed timer. So you can write to the API, but if you're writing to this API, Request Animation Frame, and it's not available on the browser that you're using, then you're going to have a problem because your application won't work. So polyfill is a small little JavaScript library. The one for Request Animation Frame, I think, is less than 15 lines of code. And it says, if I'm on this browser less than this, I'm going to create an API called request animation frame and use the older set timeout API. And if you have request animation frame, then I'm not going to do anything. So you still get the capability, the fallback capability, that use an older API that doesn't have the guaranteed timer in this API's example, but you still get the absolute ability to use and have compatibility across the applications and across browsers. So the polyfills kind of move you towards the right side and giving you more support across more browsers. Now, the next stage of actually giving you these capabilities is JavaScript frameworks, core proper JavaScript frameworks. So not all browsers have, ECMAScript 6 or, have components or whatever it is. And frameworks give you the capability to do much, much richer things inside the browser, whether that's create layout systems or UI widgets or event management or networking stacks. Frameworks give you this capability. And so Sencha, we provide frameworks for building mobile and desktop applications. And our goal here is basically to help developers become more productive by providing them a lot of the basic plumbing they need to build applications. So if you look at the web as a spectrum, basically of pages, which are kind of flat, to the promise of HTML5, which is about applications and interactive apps. Our apps, our frameworks are designed to help developers build amazing apps with web standards, but it's on apps. We're focused purely on helping developers like you build applications. So we'll do a quick tour through some of the key capabilities of what we enable so that you get a sense of how we actually help make applications in days and not in as quick as possible. In hours. So base layer, the browser provides you, as we mentioned, HTML, JavaScript, and CSS. We provide two frameworks, Sencha Touch and EXTJS, and these two frameworks are specifically designed for mobile and the latter for desktop. Inside of each of these frameworks, we provide a set of modern mobile UIs and modern desktop UIs that provide a cross-browser capability from whether it's IE6 on the desktop to the latest Chrome on desktop to Android or Chrome for Android or mobile Safari or the BlackBerry browser or the Windows 8 browser soon. Inside of these frameworks is a set of core capabilities, a foundation that's built on an object-oriented view of JavaScript. So if you're more familiar with kind of Flex, .NET, Java, application frameworks that gave you a very OO method of building applications that were structured in an MVC pattern for models, views, and controllers, that's the prescriptive mechanism that which Sencha frameworks work. On top of that, we build a set of data capabilities so that you can pull in from backend data stores or AJAX sources or whatever it might be, or REST data sources, excuse me. And those provide you the models, the stores, and the connectors to those various data elements. And then we also provide a set of UI elements, whether that's layouts and containers or UI controls. And we'll show you specifics in a minute. So Sencha Touch 2, an example, is our framework for making mobile applications easier and faster to build. So a couple examples, and these are a few examples that are built with Sencha Touch. So whether it's a consumer application like Stella and Dot, or a doctor's application such as the Blue Shield app in the bottom left, or DirecTV, which lets you schedule your DVR recordings. There's a ton of applications available to you. So I'm going to actually come out of my presentation and show you an example of an application we built for the O'Reilly Velocity event. And so what you see here is an actual app. This is running, as you can see, just on a web server. And then what you basically see here is you have scrolling inside the browser. You get a little peek behind here. One of the most powerful parts about using HTML5, using Sencha together, is the fact that you can actually get dynamic layout. So if you have an iPhone 5 or a new Android phone, you know that applications are struggling to update the new device resolutions and the new device sizes. Here in HTML5, I just resize the browser, and everything is flowed properly. I get more space. There's no work to do to resize the browser. There's no work to do to resize my elements. Using the fact that a browser is always expected that it's going to work in different size resolutions, you get that benefit right out of the box. You can see you get native scrolling, native transitions. I have search in here. I'm going to choose maybe another day here, go to the Friday event. And let's look at this conversation with the CEO. So you can see who the speakers would have been. And then this is Carol Bartz and John Batal. So I'm going to go back to the home here. And what you can actually see is you get, we're using data integration to actually pull in social information from the hashtag velocity12 hashtag, pull to refresh, which is not going to be very interesting because there's not a lot right now, and then also using locations and maps data. So we're pulling the Google Maps APIs to actually show you where this conference was, which is the Palace Hotel. So very rich, very capable. And then the best thing to show off right now is the fact that if I was to go back into the sessions list and go back to, say, Thursday, I actually reflow the page, change where it is, without having to write any new or any novel code. So apps that are built with HTML5 work great as the device ecosystem, the device landscape continues to evolve. So let's go next slide here. So we showed an example here. So hopefully most of us are engineers here or developers. So let's take a look at some code. So at the base level of all Sencha frameworks is a class system. This is where we give you a very rich set of capabilities that make it easier for you to deal with larger projects and give you a pure OO style way of looking at JavaScript. JavaScript is what they call a prototypically inherited language, and so you're able to inject things into base classes, prototypes. And so we give you an actual full OO class system. So for example, if you want to define a class, you just say ext.define in the class name. And if you want to instantiate a class, you just say ext.create. The reason we do this is we're able because you're actually doing this by reference and not by type, you're actually able to dynamically load the classes, so you're actually not pulling down all the JavaScript up front. So if you take an example here, this is a very, very simple example. We're going to create a class called animal, and the animal has a name, and that's what the config block is there for, and it has a constructor, which is boilerplate code. Now, if I want to define a human, which is a type of animal, I just say define, and I extend the base type animal. And it's going to have one function in it called speak. And speak is just going to say the console.log, so that's going to write it out to the browser console, this.getName. So the name had a config, the name was a configuration up there. And because it's a configuration, the system automatically generates getters and setters. So you have getName and setName. Now, if I want to create an instance of human here, I say ext.create. I pass in the class name here, which is human, and I give it the configuration, so the name Bob. So what ends up happening is when I ask Bob to speak, I get the console to write out, Bob. So you get a sense of, this is very kind of traditional OO style software development. So for people building large applications with tens and hundreds of screens, lots of classes, lots of views, lots of controllers, it provides you a very streamlined way to actually build and extend rich applications. To make that process even easier to build these rich, complex applications, we have a MVC model built into the framework. It all starts with an app.js, which is basically your main function, and then controllers, models, and views. Very typical, very standard. Your views, there's a view file for every UI you have, a model for every data element you have, and controllers typically for every view to help orchestrate that process. So the next thing we provide is what we call X-types. And if you're familiar with, say, XAML or MXML, this will look very familiar to you, which is it's a JSON structure. It's for typing and creating UIs. So what I have here is I've created a JSON structure here, who is a form, and it scrolls vertically, and the form contains three elements, a field set, and that field set has a text field and a password field. And so just by declaratively creating this, we'll actually automatically then generate the HTML markup, generate the code bindings that you need for it, and then do all the work that's necessary for the cross-browser compatibility. So you're very rarely, if you want to build HTML5 apps fast, you'll very rarely be working directly in the DOM because you want to make applications that work well across multiple platforms, and that's what the X-type system lets you do. The other part is the X-template system, which actually is just a simple template. If you're familiar with handlebars or mustache or other templating libraries in JavaScript, this is very familiar. The real powerful addition you get here is we have it integrated with our stores from our MVC. So at the bottom panel here, we have a list that we're creating, ext.createList. This list is bound to a store, and the store has a template. So what we're going to do is we're going to pull out the first name and the last name from the store, and that's going to show up now on my list. So you can create really rich templated data renderers and item renderers this way. So core functionality around class systems, and then assembling the UI. What do you get after you assemble the UI? We ship out of the box a lot of default touch components. So this is, you get buttons, back buttons, options, values, form fields, pickers, all that sort of good stuff. On the desktop, you get much richer capabilities for building kind of desktop class applications, combo boxes, lists, grids. But today we're going to focus on the mobile side. So we want to go fast. And with Sencha Touch, you can go very fast. You can build a mobile application like the O'Reilly one I showed you very rapidly. But if you want to go faster and you want to move very quickly, we have a product that we've built that helps this process. And the process that most people follow is the design, develop, deploy workflow. So you start by designing your application, whether it's in Photoshop or whether it's on a whiteboard or balsamic mockups or whatever your tool of choice is. And then you develop it. You start writing the code. And when you're done with developing it, you start to get it into the market, get it into production, whether it's on your internal IT servers, whether it's on Amazon AWS, wherever it is. So we had a product here originally called Designer, which lets you just basically design applications. Lets you basically create EXTJS apps, desktop apps. We wanted to make it much, much broader. What we wanted to do was merge these three processes so that you could actually build a full application in a visual drag and drop mechanism. And so that's where we built Sencha Architect 2. And what that gives you is full support for mobile, plus really rich code editing, built-in MVC, and native deployment. So let's actually jump into Architect and take a look at the application. So I've got Architect open right here. And so I've loaded up a sample application that I've built. This is an application that uses the Yelp APIs. And if you're familiar with Yelp, if you're not familiar with Yelp, if you're based out of the U.S. or Europe, basically Yelp is a local business listing service. It provides reviews and ratings for businesses who are building for businesses and for consumers to look at them. So this is the app as I've constructed it. Let's take a quick tour through Architect. On the left side here, you have your project inspector. I'm going to collapse a few of these. So you have controllers, you have your views, your stores, your models, and then resources, which is the Sencha Touch library. On the right side, you have a set of a toolbox, which contains basically all the different capabilities that we have, such as memory stores, proxies, XML readers, and then UI components like number fields, password fields. And then we have configuration down here, which shows you for this button what you want to do. If you're interested in seeing how this looks on different devices, I can choose the iPad size. I can scale it down a little bit so I can see how this app would look on iPad or Nexus S or whatever device of your choice is. Not only that, I'm going to bring this back up to 100%. You can actually see what it looks like in different orientations. So let's take a look at how this application is functioning right now. So I'm going to go to Chrome and close this guy. So here I have Yelp Touch. I'm going to refresh it. So I have a local web server running that I've deployed this app to. And so you can see it resizes depending on whatever size I want for the application. So I'm going to search for bars in San Francisco, CA. And hopefully if the Yelp API is working, I get a list of bars here that are available in San Francisco. Now let's take a look at how that was built. It's very straightforward. So here was my Yelp Touch interface. I have the search term here, which is an input category. That's the name of the field, and an input city. So what I'm going to start with is the views. So here's my main view. This is the city search form. Then I have the next view after that, which is the bars list. This is the list of bars that are actually I'm listing here. And then the details card, and we'll actually wire that up in a little bit. Then I have a set of controllers that actually help that. But at the beginning, I want to look at the code here. This is my launch function. So my launch function is basically my app main. It's my main in the C++ world, whatever it is in your language of choice. So what I do is I'm just creating a basic object that's going to hold a bunch of different elements in it. API key, which is a Yelp API key, a blank term, and a blank city. When I go back to my design view, I have this button here. So I have a tap handler connected to it. So let's go take a look at the code behind that tap handler. So what I'm doing is I'm saying the city is equal to the component input city's value. The term is equal to the input category's value. And then I'm clearing the list. Then I'm setting the title toolbar to please wait. And then the store, and we'll get to the store in a second, I'm saying here are my parameters. Here's my Yelp ID, my term, and my location. And if these things are, if I have a city and a term, then I'm going to set the active item. I'm going to move to the next card. So many mobile apps are built as a sequence of cards, and that's what we are doing here. So set active item moves me from card to card. So we saw that we started poking around in data. So let's go take a look at the store here. So here's a store called Yelp Data. It calls this URL, api.yelp.com/business-review-search. Okay, that's great. So I know that I'm going to do that. I'm going to use a reader, which is a JSON reader. So I've got this block of code here. I actually haven't written any of this code. All I had to do was drag and drop the JSON reader into here and configure it to talk to the Yelp API. And then the reader is for businesses. And so what I'm going to do is, let me try to pull up the Yelp API real fast. So business review search, open a new window. Give me a second. So first thing you can get here is it's going to say missing Yelp ID. So we know we have a Yelp ID in here. So I'm going to show you this so that you can see what this looks like. So I'll go YWSID equals this. And let's see, let's go here. So we knew that when we called the search button, let me go back to my view. We're setting a term, so we need a term in there, and term equals bars, and the other one was location. Location equals San Francisco. So this will give me back a big block of JSON. And so it's a little hard to see, I'm sure, but it says OK, and then here is the root node, businesses. Businesses have a rating image URL. They've got a country code, an ID, is closed, a city, a mobile URL, review count, etc. So there's a data structure in here. So what we want to do is we want to map this data structure that we've loaded from our store into a properly typed model. So here's our model. So you can see a direct mapping. So we had rating image URL, mobile URL, ID. And so not only do we have these things directly mapped into the model, we've actually also typed them. So ID was an int, latitude and longitude were strings. And so you can actually start adding elements into here if they existed, but we've already built this here, that are mapped directly to what was inside the Yelp API. So now that we've got this data back, we actually see the application, let's go back, the application functioning. So if I just refresh to start over again, so if I wanted to look for like cats in San Francisco, which doesn't really make sense as a search term, but makes sense enough. So whatever Yelp has for cats, we are listing here. So very cool. So now I've pulled the data in from Yelp. I've assigned it and normalized it into my model. And now my store is assigned to the list, and the list is actually rendering. But this is a mobile application, and it's kind of silly that I have to type in a city and state. I should just be able to search near me. So let's actually build that. So I'm going to start building some UI here. So I'm searching now for a button. A button here, I'm going to drag directly in, and I get a button called My Button 1. So that's not a great name for a button, so I'll say this button is called Search Nearby. So I can directly edit right from within here. Now, it's this weird gray color. It's not this nice green action color. So I'm going to set the UI style on this to a action. Oh, that's the blue. That's not quite the action color I want. Maybe I want to confirm. So confirm that nice green color. That gives us the look that we want. Now that I've searched nearby, there's two things I need to do. We talked earlier, the browser supports location. We need to start telling the browser that, hey, we need to pull the location data from that. So I'm going to go to my main, my launch function, and I'm actually going to pull in some code that I've pre-written here. So what I'm going to do is I'm going to grab this block of code, and we'll walk through it in a second, and put it in here. So what this is, we actually provide a helper function called the geolocation function that gives you the ability to just wrap the native browser APIs. So what we're going to do is we're going to set up two listeners. One that says, hey, when it's updated, let's just start with an alert and say new latitude and whatever it is. And if there's an error, let's give an error. So we basically create the class, which is the geolocation class, and we're going to say update the location. So we're going to ask the browser at that point to actually query the location API for this. So I'm going to save my project. Oops. Put this on my desktop. Actually, I'm not going to save that. I'm going to deploy it so I push it to my web directory. Oops, sorry. So we're doing a little CP and rsync here just to push the bits. And now if I go back to my website, if I go here, I'll have, oh, give me a second, that didn't work to plan. me deploy it again. There we go. So I go back here. I have a search nearby button, and the page has now given me an alert saying new latitude, new longitude. So now that's great. The browser has found my location, and I have a button that actually is going to search nearby. The next thing we need to do is wire up the location to the search capability. So I'm going to comment out the alert here. I'm going to say Yelp Touch.current location is equal to this geo object, which contains a get latitude and get longitude function. I know now that this is not the most ideal MVC pattern I'm using here in this demo. I'm using a global object to basically store and move data around. I'm doing this just for the sake of simplicity, but you kind of generally get how this would work. So now what we need to do is I'm going to go back to my design view, and I'm going to start adding a handler here for my search nearby. So what you can see down here are event bindings, and I'm going to add in an event binding for tap. What you'll see is tap automatically generates a button handler here, and I'm going to go in and start editing the code for my button 1 tap. So conveniently enough, I have written this code already. So what I'm going to do is I'm just going to steal a bunch of code from this function here, which was the search based on search term. But what I'm going to do, instead of saying location, I'm going to say use the latitude and longitude from the API. So I'm going to replace that location term with latitude and longitude, clean it up a little bit, and I definitely don't need the city here anymore. And I have this check here, which is yelptouch.city, yelptouch.term. So I don't need that check anymore, so I'm going to remove, just ensure that the user has the term set, the search term, and now we're going to pass in the latitude and longitude, and that's it. So we're going to save that, deploy it to my web server, which is a local MAMP. And then I'm going to go back here, refresh this because I've pushed new bits, make it a little wider so you can see it maybe better. I'm going to look for bars and search nearby. So now we should be searching in Redwood City, which is where I am located right now. And lo and behold, you've got a bunch of bars here that are now located in Redwood City. So that's great. So you can quickly see with Sencha Architect and Sencha Touch how quickly I'm able to actually start building a mobile application, or even just adding functionality. Within about 5 minutes, I added geolocation and geolocation search to this Yelp application. So really straightforward and really easy way to actually build apps. So quick summary. So we took a walk through how it was to build, what the state of mobile application development was. HTML5 has made a lot of progress in the last year. iOS 6 has added a ton of new capabilities. The latest versions of Android 4 have added a ton of new capabilities. Once you get up and running and you decide that you can use a framework to even accelerate your process further, you can accelerate your process even further by using a tool such as Sencha Architect. So that's where I want to stop the presentation this morning and say thank you to everyone from the O'Reilly audience. I'm going to switch over and stop screen sharing to the questions and answer pod and start answering some of the questions that you have. So let's go to the Q&A pod. Okay. So one of the questions, so actually I'll ask a question, I'll actually answer one question that I know will come up because I didn't answer it, which is around licensing and pricing and all that good stuff. So basically, Sencha Touch is actually available under 2 licenses. That's a GPL v3 license if you're building open source software, and it's available under a commercial license for $0. So you can choose either one. Some people have a preference for GPL, so we make it available as GPL. And some people have a preference for a commercial license, but that commercial license is available for free. Sencha Architect, the tool that I demonstrated at the end, is available for $3.99 per developer. So let's kind of jump into some of these questions here. So I've got a few questions here. Let me quickly refresh to make sure I got them all. Okay. So question number 1 is the Sencha Touch and Architect valuable for developers without EXTJS? So yes, absolutely. So you can build full mobile applications in Sencha Architect without ever requiring an EXTJS. You can, if you want to build EXTJS in desktop applications, that's in addition, but Architect in and of itself is available and powerful without EXTJS. So there's a question around native packaging. So we actually have our own packaging capability, which is called Sencha Mobile Packager. It's equivalent to PhoneGap in many ways, but it provides, I think, one major difference. And it's not only is it integrated into Architect, so you can one-button package your app for iOS and Android from Architect, but it's also available to package both those things from Windows. So if you're not a big Mac shop, but you still want to make iOS hybrid applications, our mobile packager lets you actually build applications using your PC. So not great from a dev environment perspective, but also really great from a build system environment. So if you're actually building, or if you have a PC in your build environment as opposed to a Mac, then you can go ahead and use our packager as well. Next question is, does one need a Mac to work with Architect? Absolutely not. Sencha Architect works on Windows, Mac, and Linux, in fact. So for the Linux community out there, we work basically provide 32 and 64-bit Linux installers. So another question, which was, this is an interesting one, does the Sencha IDE provide support for WebGL? So currently, no. Our frameworks do not consume or use WebGL today. And so, but if you wanted to use WebGL, at the end of the day, you're writing JavaScript, so you can feel free to use shaders and the GL language all you want to inside your application. There's an open source project inside of Sencha Labs called PhiloGL, which gives you more friendly UIs, or more friendly APIs. So if you're interested, you can take a peek at PhiloGL too. A question here around performance, which I'd love to answer, which is, can you talk about performance versus fully native apps? For what kind of apps and when does this become a problem? That's an absolutely excellent question. I'm glad that was asked. So you basically, I tend to recommend Sencha and HTML5 in general when you're not building a really super rich consumer application. So for most business applications, line of business, data visualization, all those sorts of applications, Sencha and HTML5 are great solutions. If you're building a game, please don't use HTML5. Not yet. It's not there. It's not ready. I'll be the first to admit that. If you're building really rich, flyouts and animations, results will vary. There may be cases when you want to build parts of that in native. There may be parts when you want to build it in hybrid or HTML5. But really when you're going for the super rich, super high fidelity gaming style consumer app, please don't use HTML5. It will not work in your benefit. Question here is, how does simulator support provided? So inside of Architect, we basically provide the ability for you, if you're on the Mac, to use the Mac simulator. And so the Mac iOS simulator. We don't have built-in support for the Android simulator yet, but basically you can push a button inside of Architect and we'll fire up the iOS simulator with your application running inside of it in hybrid mode. So it's easy if you want to start doing that, but most of the times what you'll find is you'll want to use the web browser anyway because you have all the debug tools that Chrome or Safari give you. Another question is, Sencha Architect aimed at mobile apps only? Nope. I showed the mobile application example, but since we're talking about it, let me quickly show you a desktop app real fast. So give me a second to turn screen share back on. So what I'm going to show you here is, here's Architect again. I'm going to say new project, EXTJS 4.1. We're going to create a new 4.1 project. And so in this example here, I'm going to put in a window, which is going to give me a container to put this application inside of, and a grid maybe to show you, a lot of apps need grids, and maybe a bar chart. So you can see I'm quickly assembling a desktop-style application. So EXTJS applications, which are desktop applications, are fully supported in Architect as well. Okay, let's go back to the Q&A. Okay, next question. How does Sencha compare with PhoneGap? Really good question. So PhoneGap provides you the packaging, the wrapper around the HTML. You still have to actually write the code. You still have to write the JS, the CSS, the HTML. And so PhoneGap works great in conjunction with a framework. So we provide an alternative to PhoneGap's wrapper, which is our Sencha mobile packager. But even if you decide to go the PhoneGap route, you'd still need a framework, and you'd still need a set of tools. And so our framework and tools do work inside of PhoneGap, but you have a choice on which wrapper to use, either ours or PhoneGap's, for the various advantages I spoke about earlier. So we work with PhoneGap, but if you were just to use PhoneGap, you have to write your own button handlers, you have to write your own MVC, you have to write your own event system, you have to write your own layout. With Sencha Touch, that's all taken care of for you. So the Sencha has support for HTTP pipelining. So basically, the way that that would work is it's the browser's configuration. So each mobile browser has a different configuration, and actually, from what we've seen empirically, some of that depends on the network's configuration as well. So an AT&T or a Vodafone or a KDDI or whatever your network might be, they might do stuff in between your network pipe to change the way that the traffic actually flows out. So there's nothing built into our product that changes that behavior. It's more browser and network specific. Okay, let me just. So we have a question here, which is, does it build native Android and iOS? Well, we build hybrid applications. So you can build it and deploy to the web, which is what I was showing with the O'Reilly app and the Yelp application, or a hybrid application where you can basically push it into the App Store. So they're native in the sense that, yeah, they come in a native wrapper, but the core of the application is HTML5 and Sencha. So another question down here, which is, do we support core data? Is there support for something like core data? Where did that question go? Oh, somewhere in there. Okay. Do we have support similar to core data as found in iOS SDK? So depends on what features in core data you're looking at. So there's a capability, a name value storage inside of HTML5. It's called local storage. It's access to the local storage API. It has very simple APIs like set value, get value, lookup value. That's basically it. So you have that. Then there's two other data storage APIs inside the browser. One is called WebSQL, and that's supported. And this is actually this is probably one of the big gaps in the HTML5 spec right now. WebSQL is well supported by Safari and Chrome. Firefox supports an alternative called IndexedDB. And then I'm not actually sure what Microsoft is doing inside the Microsoft camp because they have their own database views. But both of these provide a structured API. So if you want more than just name value storage, either WebSQL or IndexedDB provide you the structured capabilities that you can use for data storage. Okay, so kind of a similar question, which is, can I use a SQLite database on iOS devices using Sencha Touch? If you want to use the native SQLite inside of iOS, which iOS and the Cocoa APIs provide, you can use that via a plugin to PhoneGap or Sencha native packager, or Sencha mobile packager, excuse me, and then use those JavaScript APIs that that bridge API gives you. So then you can use the SQLite database. WebSQL, the WebSQL API, uses SQLite underneath it, so you get effectively the same thing if you want to go that route. Okay, let's see. Can I access the Canvas tag with Architect? Out of the box, no, we don't provide support for the Canvas tag. We don't provide you, I mentioned this a little bit at the top, which was we don't provide support for a lot of DOM. So we expect that in most applications, apps will be, you write with our X types, you provide the declarative syntax in JSON, and then we generate most of the DOM for you. Now, if you want to do your own DOM elements, EXT and Sencha Touch both provide really rich DOM handling capabilities, similar to, like, say, jQuery does. So you can easily create, you can say create element by ID or whatever it is, or create element, and create a Canvas tag, and then let it participate in the layout mechanism. But out of the box, we don't have a drag and drop Canvas element. Okay. Does Sencha Touch provide file upload control? So no, we don't, because this is basically very new. This is very new inside of iOS 6 and a lot of the other and the latest Android, where file upload support is specifically for media, for photos and video. So we'll be looking at adding support for that very soon. Question, Touch charts. Rumor has it they will be embedded in the next release of Touch 2.1. When is that coming? So we're not commenting on specific release dates. Sencha Touch 2.1 is available in Beta 3 or Beta 4 form right now, and it does include Touch charts. There are specific licensing requirements that you should look at that are posted on our Sencha forums, but Sencha Touch charts will be included as a part of Sencha Touch, and betas of that are already available today inside of the Sencha forums. would you recommend Sencha for users with minimum coding knowledge? That's a really good question. And I think the honest version of me says, if you want a designer or developer to build and assemble the UI through application, give them Sencha Architect. Because what they can do is they can build the UI, they can set up the screens, they don't have to write any code, and then they can hand it to your engineers to actually build and implement it. But if you want to have just one person who doesn't know much about coding to build a fully functioning application, that's going to be a little bit tough on our platform. You kind of need to build in the actual wire up and the functional side of the application. You do require some amount of coding knowledge. Okay. So this is an interesting question. So do you have support for the D3.js library, which is mainly used for charting and visualization with web standards? So we don't support D3 specifically. We don't really support any third-party charting and visualization APIs. Plenty of people have integrated them into Sencha Touch. And if you go to the Sencha market.sencha.com, you can see third-party libraries that are built on top of our frameworks. And D3, I don't believe, is on that list, but somebody in the community might go ahead and do that. Sorry, I'm just doing a little hygiene here, make sure. So this is a really good question. You're talking about new functionality in new versions of the OS. How much can we rely on mobile users having the latest, greatest? I really like that question because it speaks really specifically to the difference between the iOS and the Android ecosystems. iOS, I think the numbers I saw last week were about a quarter of all iOS devices have been upgraded to iOS 6. So the iOS universe, you can really rely on end users upgrading very rapidly. Android, on the other hand, you cannot rely on that. So if I was to make just kind of a generalized claim, iOS you can kind of rely on like 30 to 90 days, enough users are having it so you can rely on the new OS features. Android looks closer to classic mobile hardware, where you're relying on a 2-year cycle to get updated because they're really relying on new devices to be purchased from their carriers or for the consumers. I think the numbers I saw were like less than 2 or 3% are updated to the latest Android. And so you have a real split there between how the behaviors work on both those ecosystems. Okay, there's another one that was interesting here. Can I develop in iOS if I don't have Apple hardware at all for Windows, for instance? So yeah, actually with Sencha products you can do exactly that. You just get Chrome, you use our mobile packager, you debug and develop the application using Sencha Architect and the Chrome browser, package it up with our mobile packager, and then when you're done, you can just upload it to developer.apple.com. Now, I would just generally recommend, and you can also even test it on device using iTunes. So I generally recommend you may want to try it on a Mac just so you can see what it looks like in the emulator because the process of copying and uploading an app with iTunes is just a lot of work. But it's possible. It is absolutely possible because we give you all the tools on Windows. Question, is HTML5 a good tool for data-driven mobile sites? Oracle, back-end, back of that question is getting cut off. So yes, so we have a couple of really good examples here. We have a partnership with SAP, and the SAP back-end, you can use the OData providers to build mobile applications, and SAP was demoing that at their Sapphire events and at their Tech Ed events. We also provide capabilities in our Sencha Complete Team package, which would let you actually connect to SOAP data services, which Oracle or any SOA architecture would provide, and AMS services such as BlazeDS or Lifecycle Data Services. So yeah, it is an absolutely good tool for doing that. We find a lot of our customers are building right now for tablets dashboard apps to mobilize a lot of their enterprise application backends. Okay, I think I have time for one, maybe two more questions. Let me just hit the refresh here. Let's see. So yeah, I'll answer these two. Are the components listed in market.sencha.com tested and validated by Sencha? So they are, we've looked at them, we've approved them to make sure there's no malware and there's nothing evil about them. But what they do insofar as do they do what they say they're going to do, that's up to the component author to verify. We don't verify that. But it's a great resource to actually go find what is there, and we do verify the listings are by reputable sources and all that on the market. And then the last question I think I'll answer which is around back-end server technology to integrate with. So I'll answer it more generally, but it's, can we use JSP as a server-side coding language in Sencha Touch? And the answer is use JSP, use ASP, use Ruby on Rails, use Python, use Perl if you want to. We look at the back-end as a data provider. So if you're talking REST, if you're talking XML, you're talking SOAP, any one of these technologies, we can easily connect to those back-end services. So it really doesn't matter what your back-end technology looks like. All it really matters is that you're providing a REST interface, and then you can use a JSP basically to deliver all the HTML and CSS that's required for the app. So it works absolutely well in basically any server-side environment. Great, so I think that's basically all the time I have for today to answer questions. I do want to remind attendees that anyone interested in taking Sencha training, for people at the who are attending the webinar, using the code O'Reilly and the number 5, you'll get 5% off of Sencha training. So just a little thank you for listening in to what we've been talking about today. So again, really excited to have the opportunity to speak to everyone here today. We're very excited. We're very bullish on the future of HTML5 and mobile, and we hope that you are too after seeing a little bit about what the future of mobile and HTML5 has to offer. Thank you.